Video 2, we're going to use NumPy to create 3 elementary row operation functions. Before we program, let's real quick remember some of the math behind it, realizing that when we multiply a matrix on the left-hand side, that what we're really doing is row operations. Therefore, if you want to go back and review linear algebra lesson 3 from string, you can go back and look at that video and sort of remember some of the things. I will help do that, but I'm not going to go into the excruciating detail that he did in his video. So I'll let you go back and check that out from your algebra class. But just remember, if we're multiplying a matrix, and so all of these matrices that I'm sharing with you right now, this is the matrix A that we're trying to do something to, and this is the operation that we're doing to it, right? So this is the operation. And because this is a 1 by 3, so this is a 1 by 3, and this is a 3 by 3, then we expect to get a 1 by 3. So let's real quick just go through what happens when we, so let's take this row and multiply by this column, and all we do is multiply that, and we get a 2 there. And when you take this row and multiply by this column, we get a 4. And when we take the same row by this next column, we get a 6. So just realize that all we just did was we took the matrix A and we multiplied it by the first row by 2 to get the one row that comes out of it. So what would happen if we took maybe something a little different? Maybe what happens when we take 3, 0, 0, 0, 2, 0. So think about what is going on with the actual multiplications, right? So again, this would be a 2 by 3. This would be a 3 by 3, and we would end up with a 2 by 3 again. So 2 rows. Because we have 2 rows here, we would have 2 rows in our result. So again, this is our matrix A that we're trying to do something to, and this is the operation. So let's figure out what it does. And so just like before, when I take this row and multiply by each one of these columns, all we're simply doing is taking whatever this number is and multiplying it by each one of these numbers. So that would just simply be 3, 6, and 9, just like you would suspect. And then think about what happens now, right? So now I have the second row times this is, so that's a 0, that's a 0, and the only thing that happens is the 2 times the 4, so we would get an 8. 2 times the 5 would be a 10, and 2 times the 6 would be a 12. So in effect, what we just did was we took 3 times row 1 and 2 times row 2 to get the 2 rows that are in the new matrix, the 2 by 3 matrix. Okay. So let's sort of keep going with that idea. I'll use another color here. Suppose we started with the identity matrix. Suppose this was a 1 right here, just for a second. So if I multiply by the identity by this, we would get exactly the same matrix. So this would be my matrix A, and we would just get matrix A again. But now what I did was I just took one of the ones on the diagonal, and I replaced it with a 3. So what happens to the matrix A now? What's the only thing that changes? Well, as you can imagine from above, now I'm taking this row and multiplying by this column. So the only thing that I'm doing is multiplying by the 3. So I get by the 1. So 3 times 1, 3 times 2 is 6, 3 times 3 is 9. And then what happens now? So again, just like here, where all you ended up doing was multiplying by 2, now I'm just multiplying the middle row by a 1, and then the last row by a 1, right? So the middle row times a 1 would just simply leave us with exactly the same thing that we had from the beginning. And then the last, the 0, 0, 1, we get the same row that we had at the beginning. So let's take just for a second, look and see what happened here. All we did was we took this matrix. I'm going to call it E. We'll call it E1. So I'm just putting the sub matrix or the sub bullet down there just to make sure that we could possibly have multiple of these. And that's what happens when you're doing this in your linear algebra class. You end up getting a lot of these E's and multiplying them all together. But in this particular case, all I'm doing is multiplying the matrix A by this E1 matrix, And that is the same thing as just taking this first row and multiplying it by 3. And then everything else stays the same. So if I wanted to multiply the second row, let's don't do it by 3. Let's do it by -2, just to be a little different. So that would, so this right here, oops, this tells us that this row is going to be exactly the same. So I can just come here and write 1, 2, 3. 0, -2. This to me means I'm going to take the second row of this matrix and multiply by -2. So -8, -10, and -12. And then this row here says that I'm going to take this matrix and the last row is going to be exactly the same as before. Okay. So I think if you do enough of these, you'll figure out that if you start off, so if you do this kind of ERO, and remember what ERO stands for, I'm not sure if everyone does, but elementary, so elementary row operation. And if you start with the identity, and this elementary row operation is the one where we just multiply some row by a constant. That's all we're doing. Just take one row, and that's literally what we did in this example, right? All I did was I took A, and I just changed the first row by multiplying by 3. So if we start with the identity, right? That's basically what we did here. And then change the diagonal entry for the row that we want to change. For example, 1. So in entry 1, 1, we change it to the constant that we want to multiply it by. And then matrix multiply on the left, which is what we just did here with this multiplication. Then you get the new B that does exactly what we want to do with this one elementary row operation. Okay. So let's talk about, so we'll come back and we'll look at this guy, because I'm not sure if we're going to have enough time in this in this lesson to do it, but we might come back and program this here in a few minutes. But I want to show the math before we do that. All right, so elementary row operation 2, so ERO2 is this one, ERO2, and that one's just row exchange. And what do I mean by that? Well, if you had 1, 2, 3, 4, 5, 6, 7, 8, 9, this row exchange is going to take 4, 5, 6 and put it up 1, and 1, 2, 3 and put it on the second row. So it's going to take your second row and put it in your first one, and your first row and put it in the second one. So that's what that's the purpose of this, and I call this P. And if you remember from linear algebra, why did I call it a P? Think about that for a second. So I'm going to do this multiplication, and then we'll come back and we'll talk about that. So take the first row of this new matrix is going to be basically the second row time. So take this first one and then multiply by 4, then multiply by 7, and you get just 4. And then you get just 5, and you get just 6. And then the second row is the second column, which is just 1, 0, 0 times this matrix we know is just the first row by what we just talked about here a second ago. And then the last row is just the last row, right? So it's just 7, 8, 9. All right. So all we did, so check out what we did here. All we did was we took the first row, and exchanged it with the second row. That is the result here. We'll call it PA. Yeah, I forgot to write the A there. And so this is also the A that we're worried about. And then this one, what does it do? It takes the third row, P321, takes the third row and puts it in the first. The second row puts it in the first, and first row puts it in the third. I'm sorry, 3 into 1, 2 into 2, 1 into 3. So basically this is just exchanging the first and third row. All right, let's see what that looks like. So here we know, remember, row times this matrix just says just take the last row. So 7, 8, 9, and you can multiply that if you don't remember that. This one means just take the second row. So 4, 5, 6, and this last one is just grab the first row. 1, 2, 3. Again, all you did was you changed this one and this one out now. Okay, so it's called a permutation, right? So P is a permutation matrix, and the way that I write it is a little different than what String writes it. String writes it in his text. I put a 1, 2, 3 here, and the reason why I do that is this tells me that start with the identity and put, and this one isn't really a permutation. This would be the identity, because I would take the first row of the identity and put it in the first row of this matrix, the second row of the identity, put the second row, and third row, put in the third row. This says take the second row of the identity and put it in the first row. That's why you have 0, 1, 0. Take the first row of the identity and put it in the second row, and take the third row of the identity and put it in the third row. So why do I write it like this? Is so I can simply go, well, how many of these do we have for a 3 by 3 matrix? Well, I have 1, 2, 3. I have 1, 3, 2. I have 2, 1, 3. I have 2, 3, 1, and I have 3, 1, 2, and 3, 2, 1. So just so you remember, I'm not sure if you do or not, but it's just the number factorial. So for example, this is a 3 by 3, so it's a 3. 3 factorial would be 6. So I have 6 different ways that I could exchange rows in a 3 by 3 matrix. Okay. So how would I generalize this and use it in programming here? So all I'm going to do is start off with the identity. So row exchange is done by starting with the identity. So right here, starting with the identity, and then exchanging inside the identity. I'm just going to turn it into a permutation matrix by exchanging rows, which is to realize we could have just done that with the A matrix. What I'm trying to do is come up with always doing it with matrix multiplication. So I get that. I get we could have just exchanged these 2 rows and been done with it. But I want to always do this with matrix multiplication. So I'm going to come up with a permutation matrix, and then I'm going to matrix multiply. So whatever the permutation matrix is times A is going to give me B. Okay. How much time have we got? Oh, we're not going to get a chance to go program it, but that's fine. We'll do it here in a few. Okay. So in this example, if I start off with the identity matrix. So this is ER03. I'm not sure if let me kind of do a giant blue line here. ER03 is multiplying one row by a constant, and adding it to another to replace a row. Okay, so in this example, what I want to do is I want to get rid of this 4 here. All right, that 4 sort of annoys me a little bit. Why? Because I'm going to I want to do row reduction. So if I'm doing row reduction, then these can be numbers, but everything below that needs to be zeros. And so that's the first sort of step that you want to do in row reduction. So I would like to take -4, multiply it by row 1. Right? I want to take this whole row here, multiply it by -4, and then add it to row 2, and then I want to replace row 2 with that one. Right? So in other words, row 2 is equal to -4 times row 1 plus row 2. That's the idea. How can I create a matrix starting with this one? I mean, I sort of just wrote it here. I could have erased, but I want to start with the identity, and then I want to change this guy so that it does what I want it to do here. So so remember what happens when I multiply on the left, it's all going to be a row operation. So I'm going to so I want 1, 2, 3 to be in the new matrix. Yeah, so we want to do something that does exactly that. So let's do this. How can I do this with matrix multiplication? So I'm going to do 1, 0, 0. Why? Because I want this to be still 1, 2, 3. And that's my row operation for this first row of the new matrix. The second row is the one that we need to change. And the question is, well, what are you doing here? So let's come back and look at this piece. What's happening here? I need -4 times row 1. What does that mean for this row? When I take this row and multiply it by this column, where do I want the -4? I want the -4 times that guy. And then I want the -4 times the 2. And then I want the -4 times the 3, and then add it to 6. So I want that -4 to sit right here. And then because I'm just multiplying this row by 1 and adding it, I'm going to put the 1 there and the 0 there. So let's just make sure that it does what we want it to do. So -4 times 1 plus 1 times 4, and then times 0 gives us 0. So that's good. That's a good thing because that's what we were trying to get rid of, that 4. And then -4 times 2 is -8 plus 5 is -3. And then -4, -12 plus 6, I believe that's -6. And then what would we do if that's only operation that we want to do? So we're going to do these sort of one step at a time. Then again, remember, it's an elementary row operation, right? It's not a very complex row operation. So we just want to do one step at a time. And then 0, 0, 1. And then this would tell me just to rewrite 7, 8, 9. Okay, that's all I got for this video. We will program this next class or next video.